Hello students, again welcome back to the continuation part of sequence series as we discussed very interesting questions, very interesting pattern concepts in the previous video. So in this video we will extend our idea, we will build our theories and we will develop the own ideas and we will try to cover up the portion. Okay, so it's very important. So what kind of question you may get in any entrance examinations or any competitive or any maybe theory exams situation. So yes, so this will be very interesting. Okay, find the sum to n terms of the series. Find the sum to n terms of the series whose n term is n term is n into n plus 2. Okay, so this will be the question which you will get. So I guess this is the question we already discussed. So it's nothing but n plus 1. So another very interesting question. So again, you know how to do this question. We already given n, so or Tn you can call nothing but n square plus n. Let me revise this. So Sn is nothing but summation of ak, where k is from 1 to n, which is nothing but summation of k from 1 to n, k square plus k, and I know this thing as k from 1 to n, k square summation k from 1 to n k. Therefore Sn is equals to, you can say n into n plus 1, 2n plus 1 by 6 plus n into n plus 1 by 2. So Sn is equals to n into n plus 1 by 2. It is nothing but 2n plus 1 by 3 plus 1. Yeah, because already you took this thing out. So this is nothing but n into n plus 1 by 2, 2n plus 1 plus 3 by 3. So which is nothing but n into n plus 1 into 2n plus 4 by 3 to the 6. So this thing you can easily cover up the problem. So when n terms is known to you, you can easily manage. So this is the revised. Okay. So it's a revision so that you can easily manage that problem. Now let me extend my idea. Let me take very interesting concept that they will give like find the sum to n terms of find the sum to n terms of the series 1 into 2 plus 2 into 3 plus 3 into 4 up to n terms. 1 into 2, 2 into 3, 3 into 4 up to find the sum to n terms. They have given that. They clearly mention they want sum to n terms. So what is essential in sum to n terms? Nth term is essential, but the bad luck is n term is given, not given. But we are very fortunate, we can easily predict n term using the concept. Now what I can say here is, here Tn is nothing but, look at the pattern, look at the first term, 1, 2, 3. Yeah. So you can say when it is 1, 2, 3, n term is given by a plus n minus 1 into d. A is 1, n is n minus 1 only, d is 1. 1 plus n minus 1, plus 1 minus 1 they cancel n. So the first term is n. Into, look at the second term, 2, 3, 4. So for 2, 3, 4, same formula. First term is 2 plus n minus 1 into 1. So 2 plus n minus 1, it is n plus 1. Yes or no? Because n and this is 2 minus 1 is 1. So I can say n into n plus 1. And just now you got solution of this. Therefore, Sn is equal to summation of k from 1 to n tk, which is summation of k from 1 to n k square plus k. I will write directly. So k square plus k, which is nothing but just now we got answer k from 1 to n k square plus summation k from 1 to n k. Therefore Sn is equals to n into n plus 1 into 2n plus 1 by 6 plus n into n plus 1 by, so I can say n into n plus 1 by 2 is out, n into n plus 1 by 2 is out, so I can say 2n plus 1 by 3 plus 1, and you can write answer directly n into n plus 1 into 2n plus 4, because 3 ones are 3, 3 plus 1 divided by 6. So this is the way we can get answer for sum to n terms of this series. Okay, when n terms is not given, using the basic idea, bring the n term and then add this n term, you get sum to n terms. Okay, so this is the solution of this question. Now we'll discuss another interesting question. Find the sum to n terms of the bit interesting question we'll discuss. 1 by 1 into 2, 1 divided by 1 into 2 plus 1 divided by 2 into 3, 1 divided by 2 into 3 plus 1 divided by 3 into 4. Okay, so they already mentioned sum to n terms of the series, but n terms is not known to me. So I can say Tn is equals to 1 divided by 1 into 2 into 3 is n into 2 into 3 into 4, just now we computed n plus 1. Okay, therefore Sn is equals to summation of k from 1 to n tk. Yeah, so which is nothing but summation k from 1 to n tk. So tk is equal to 1 divided by k times of k plus 1. Yeah, so we can say this thing as summation k from 1 to n. We can say this as a 1 by k square plus k. Yes or no? So k square plus k. So it is nothing but you can easily compute. So we just so k square plus k. So we got to know what is k square. So we kept it like this. So which suffices to me to say that Sn is nothing but summation of k from 1 to n, 1 divided by k square plus k. Because if you want to find first 3 terms, put k from 1 to 3, you will get easily answer. So this is nothing but sum to n terms of this series using this wonderful concept. Okay, fine. Now we will discuss. So there are many questions given at the end of exercise. You just take care of this question. Let me move on to the bit interesting question. As I told in my beginning of the session, and one thing I will tell you here, if you want, you can expand using some interesting facts. So just work out as an exercise. Okay, it's given in textbook, so you can easily manage. It's not a difficult one. If you want, you can express. Okay, fine. Now we'll discuss very interesting pattern. So what is the pattern here? Is find the sum to n terms of the series. Okay, find sum to n terms of the series 5 plus 11 plus 19 plus 29 plus 41. Look at this. Find the sum of the n you check this, okay, I want sum to n terms. So write Sn is equal to 5 plus 11 plus 19 plus 29 plus 41. Okay, let me write this as a Tn, n now, because they expected Sn, sum to n terms. But if you observe carefully this series, it is neither AP nor GP. 11 minus 5, 6. 19 minus 11, 8. The gap is different. 11 by 5, something in point. 19 by 11, something in point, which are not coincident. What to do in such case? What you felt personal? So to solve such question, where you will get neither AP nor GP, there is one logic they will implement. What is that logic is? They will call this method as a method of difference. Difference means what? Subtraction. But how to bring this method is, they will write again Sn, but instead of writing 5 here, they will write next is 11, 19, 29. Here they will write Tn minus 1, and here they will write T. Hope you understand. And obviously the previous term is Tn minus 2. Now subtract these two. When you subtract these two, you will get 0, which is equal to 5. Okay? If you want, you write it. 1, 2. So write 1 minus 2 gives 1 minus 2 gives. So Sn minus Sn 0, 5 minus 0, 5, 11 minus 5, 6, it is 8, 10, yeah, it is 12, yeah, 29 plus 2, 31%, yeah, correct. I guess this Tn minus 1 minus with the previous Tn minus 1 cancel, this Tn minus 2 previous cancel, yeah, and you left with the term Tn minus Tn, yeah. You just imagine what you left with. You left with Tn minus 1, yes. So minus Tn. Yeah, you just think how it is possible. So you left with minus Tn. Now what I will do here is, I will bring this Tn on this side. You get Tn is equal to, what I will do here is, okay, I will not consider this into this group. I will keep this as it is. Okay, I will write this. So 6 plus 8 plus 10 up to, that is n minus 1 terms. Okay. Now Tn is equal to 5 plus, we know sum to n terms of any sequence. Now I guess it's AP. 6 minus 8 minus 6, 2, 10 minus 2. Okay. So sum to n terms. What is the formula? Sn equals to n by, okay, n by 2 into 2a plus n minus 1 into t. Yeah. But in place of n we have n minus 1. So write n minus 1 by 2, 2a plus n minus 1. Okay. Into d. Is 2. So Tn is equals to 5 plus n minus 1 by 2, 12 plus, okay, so just multiply, or you can write this as a n minus 2 times of 2. Understood? So Tn is nothing but 5 plus n minus 1 by 2, 12 plus 2n minus 4, Pn is equals to 5 plus n minus 1 by 2, 2n plus 8. So Pn is equals to 5 plus n minus 1 into, here also I take here 2 common, so you left with n plus 4. Yes. So if you take 2 common, yeah, n plus 4. So Pn is equals to 5 plus n square plus 4n minus n minus 4. Yeah, n square plus 4n minus n minus 4. So Pn is equals to 5 plus n square plus 3n minus 4. So Pn is equals to n square plus 3n plus 4. So therefore I got n term, but I am in a search of sum to n terms, right? Therefore Sn is equal to summation k from 1 to n tk, which is summation k from 1 to n. Tk is k square plus 3k plus 1, which is summation of k from 1 to n. K square plus k from 1 to n k plus summation k from 1 to n 1. So we know this answer. So we know this answer. This answer as n into n plus 1 into 2n plus 1 by 6. 3 times of n into n plus 1 by 2 plus it is repeated n times. So this is the sum of n terms of this series. It looks like it's not neither in AP nor GP, but when we apply the difference method, we got its answer. So not all questions can be impossible. So there are few questions which is impossible to solve in series, but there are few questions which you can use technique of difference method to get easily answer. So that's it from the series problem of this difference method. Now there are many questions given at the end of textbook. You can easily solve these questions. Okay. So there are few questions given. So this is very interesting. Okay. So difference method is very much useful when it is neither AP nor G. We will discuss next question. Find the sum to n terms of the series whose n term is whose nth term is 2n minus 1b whole square. Okay. Find the sum to n terms of the series whose n term is 2n minus 1b whole square. Now, already given n term, so here I can say Tn is equals to 2n minus 1b whole square. Therefore, Sn is equals to summation of k from 1 to n 2k minus 1b whole square. So then Sn is equals to summation of k from 1 to n a square, okay, minus 2a, 2 into a into b plus b square. So which is nothing but summation of k from 1 to n 4k square, summation of k from 1 to n 4k, summation of k from 1 to n 1, which is 4 outside, summation of k from 1 to n k square minus summation of k from 1 to n k plus summation of a from 1 to n 1. Yeah. So this is 4 as it is. You can write this as n into n plus 1 into 2n plus 1 by 6 minus 4 times of this, you can say n into n plus 1 by 2, yeah, plus this is repeated n times. If you want, you can simplify these expression, but it's more than enough for this problem. So this is called as sum to n terms of the series whose n term is known to me. Okay. So similarly, they have given many questions. You can take care of this question. Let me discuss one more interesting question. Find the sum to n terms of the series whose n term is n square plus 2n. N square plus 2 raised to n. So this is the question whose n term is known to me. So what I will do here is Tn is known to me. N square plus 2 power n is not 2n, 2 power n. So Sn is nothing but summation k from 1 to n. Yeah. K square plus 2 power k, which is summation of k from 1 to n, k square plus summation of k from 1 to n 2 power k. Yes. Now I know this can be written n into n plus 1, okay, into 2n plus 1 by 6. But I don't know about this thing, but I can easily predict this easy answer. If you put k equals to 1, it is 2. Okay, 2 square, 2 cube, up to n terms. Yeah, it is 2 power n. Therefore, what I will do here is n into n plus 1 into 2n plus 1 by 6 plus. It is like GP, AR, 2 into 2. So the sum to n terms, okay, of a GP you know. So A into R power n minus 1 upon R minus 1. Yes. So in the next step you can simplify it as a n plus 1, 2n plus 1 by 6 plus 2 times of 2 power n minus 1, because 2 minus 1 is 1. So this is called as sum to n terms of this particular series whose n term is known to me. So n term is n square plus 2 power n. Okay. So there are n number of problems are given. We just take care of this question. So let me discuss one more very interesting question. Okay. And let me wind up your portion of sequence and series. So there is one more interesting question is given. N into n plus 1 into n plus 4. Yeah. So this problem is given. Find the sum to n terms of the series whose n term is given. So Tn is n plus 1, n plus 4. It is better if we simplify this n as it is. It is n square plus 4n plus n plus 4. Yeah, n square plus 4n plus n plus 4. So when you multiply, this becomes n cube plus 4n square plus n square plus 4. And you got n cube plus 5n square plus 4. 4n, right? So n cube plus 4n square plus n square plus 4n. So n cube plus 5n square plus 4n. Therefore, I can say Sn is nothing but summation of a from 1 to n. Okay, pk. So I can say summation of a from 1 to n. K cube plus 5k square plus 4. Yeah. So I can say this thing as summation of k from 1 to n, k cube, summation of k from 1 to n, 5k square, summation of k from 1 to n, 4k. Now this is nothing but n. Now you know in induction 1 cube plus 2 cube up to n cube can be written as n into n plus 1 by 2 the whole square, or n square times of n plus 1 the whole square by 4. Yeah, so you can say this thing as n square into n plus 1 the whole square by 4 plus 5 times of, you can say this thing already you know this, n into n plus 1 into 2n plus 1 by 6, right? Next, 4 times of n into n plus 1 by 2, right? So if you keep it as it is, it's fine, but it's better we will simplify a bit. We can say n into n plus 1 by 2 is common, n into n plus 1 by 2 is common. When you take it out, you left with n into n plus 1 by 2, because it is n square, n plus 1 the whole square by 2 into 2, plus you took 3 common, so 2 common, so n into n plus 1 is 5 times of 2n plus 1 by 3, because 2 3s are 6. Here you took already n into n plus 1 by 2 is common. So this is the sum to n terms of the series whose n term is known. So any problem based on such category you can solve by this very interesting method. So all you need is n term, and next you want the formulas you studied in mathematical induction, you need to memorize. As I told, not for only passing package you have to learn this in future. You need to memorize what is sum to n terms of first natural number, sum of first space of natural number, sum of first cube of natural numbers. All you need. You just take care of all these problems in a systematic way. If you know n term, you can easily write it. So, okay, that's it from the second series chapter. I have chosen few very interesting questions from exercise, okay, which is very much useful for your future. So there are many questions which is left as an exercise for you people. Don't depend much on me or me to solve. You show some interest, so try to solve this question. If you not find any answer, you just approach me. So don't depend much on me, because whatever is difficult, whatever is very important for your future, I'm not saying they are not important. They are also important, but you can manage them in a very ground level. So please take care of remaining questions. Try to solve questions. Okay. In sequence series, what is very much important is in the first sequence, if you know arithmetic progression, that too you know arithmetic progression, so criteria. Then sum to n terms of AP, n by 2 into 2a plus n minus 1 into d. Okay, so this is for AP. And for GP, sum to n term, you know 2 times of formula. R over n minus 1 divided by r minus 1, or a into 1 minus r over n divided by 1 minus r. But I asked you one question in the offline class and regular class. What will be the answer for S infinity for an AP? Okay, this is still infinite only. You just take. But for GP, I told in my regular class, S infinity is given by a divided by 1 minus r. So this is the formula for sum of infinite terms of an And next you know arithmetic mean insertion, geometric mean insertion. So arithmetic mean between two numbers a and b is given by a plus b by 2. And geometric mean between two numbers is given by root ab. If anyone asks you the question, what is the geometric mean of 2 and 8? You can easily answer them as a 4, because the formula is 2 8s are 16 is 4. So if anyone asks you what is the arithmetic mean of these two numbers, you can answer them as a 5, because we know arithmetic mean formula is 2 plus 8 by 2. So 10 by 2 is 5. And there is one more thing. Okay, arithmetic mean is always greater than or equal to geometric mean. If you observe here 2 and 8, okay, its arithmetic mean is 5, because 8 plus 2 10, 10 by 2 is 5. But when you take this 2 8 is 16, root 16 is 4. Here we can say that 5 is greater than 4. So there are some cases you will get arithmetic mean is equal to geometric mean. That we will discuss in entrance exam. But one thing you always keep in mind, arithmetic mean is always greater than or equal to geometric means. And we studied insertion of arithmetic mean, insertion of geometric means when a sequence is neither AP nor GP, how to manage. So all we discussed. So this is one of the very interesting chapter. In future you will have a very much plus point when you study this thing. Okay, so that's it from the sequence series chapter. In the upcoming session I will discuss entrance questions of sequence as well as series, and that's it from the sequence series chapter. Thank you very much. Take care. Have a nice day.